Hello everyone, and welcome to the third lecture in the Student Machine Learning Coalition's lecture series. This lecture will be about Pandas. So we'll be talking about what is Pandas, how to install it and use it, and then series and data frames, which are the two most common things that you'll be using Pandas for. So to begin, what is Pandas? Pandas is a Python library that's very closely related to NumPy. You'll see a lot of crossover between the two, especially when it comes to series and a little bit with data frames. You'll see. They both go hand in hand. Pandas is very useful for manipulating and storing data, so cleaning, transforming, analyzing. We'll go over a little bit about what that means, and you'll see some examples as well. It's very similar to Excel, Microsoft Excel, but you'll see that it has a lot more features and flexibility. You'll see a little bit of these similarities when we go over data frames. So, to install it on your computer, if you have the Anaconda distribution, then you can type in conda install pandas into your command prompt. Or if you don't have the Anaconda distribution, you can type in pip install pandas into your command line. To import it into your project or your notebook, whatever you want, you can type in import pandas as PD. Of course, right next to import numpy as np, because you need both of them. So, series and data frames. Series are very similar to NumPy arrays. They store one-dimensional data. And just like NumPy arrays, they both have indexes and their data itself. Indexes are more flexible than NumPy arrays because they aren't limited to numbers. So instead of accessing the data from a 0 to 10 or a 0 to however many objects you have in your array, instead of using those numbers to access the data, you can change it to strings or whatever you want. You can, letters, strings, whatever. So instead of, for example, in this example series, instead of accessing the blue string through the number 2, you can access it through the letter B or the word happy if you want. You can change that around a little bit depending on what you want. And then the data itself can be anything. You can have numbers and strings and dates, and the series isn't limited to one type of data. So now data frames, and this is where you'll start to see some similarities with Microsoft Excel because it looks like a table. And it is essentially a table. You have your index labels, and then you have your columns and whatnot. So a data frame is a collection of series. Each row is one Pandas series, and you compile them into a data frame. So you'll have your index label, and that's how you access each individual series. And then you'll have your column names, which is how you group objects in each of your series. And then you'll have your data. So in part of your data, you'll have missing values on occasion. So those NaNs right there, those are null values. And we'll talk a little bit about what that means, what those are, how to deal with them in a bit. So some important data frame methods. What can you do with data frames? So to begin, df.head gives you a quick picture of the data, quick snapshot, if you will. By default, it'll return the first 5 rows of your data frame, but you can change that depending on what you want. If you want the first 2 rows, you can put the number 2 in between the parentheses. If you want the first 10 maybe, then you can change it according to your will. df.info provides important details of the data frame, so things like number of rows, columns, types of data, null values, things like that. df.shape is similar to the .shape method that you would use for a NumPy matrix, but it's for a data frame, so it'll output the dimensions of the data frame in a tuple. So how do you access the data in a data frame? Well, one way is by using df and then at the column name, and that'll return the specific column in the form of a Pandas series. So if you want to access entire columns, you can go ahead and do that. And then .iloc and .loc are both ways of accessing specific data in the data frame. .iloc is index-based location, and .loc is location. We'll talk a little bit about what those are more specifically in the implementation notebook, where you can see some examples as well. And then df at the column equals whatever will return whatever columns or rows fit a specific condition. That's called conditional selection. Again, you'll see some examples of what that looks like in the implementation notebook. All right, and then .apply. .apply essentially applies a function to the data frame or to a specific part. So you can either write out a function, def, and then whatever your function is, or you can use it in lambda notation, which is much more concise. Neither is better, they're just different. So the example we have here is splitting a certain string apart and creating a new column. So df new column is equal to df and then whatever your old column name is, dot apply, and then you can see that lambda function in that parentheses over there. So this specific one will pick out the first word before the colon. Now null values. When dealing with missing data, which is what a null value is, it's just the absence of data, and so NaN is what's automatically kind of filled in there. With null values, you can either drop them or fill them in. To drop values, to get rid of them, or to drop columns or rows, whatever you want, you can use df.dropNa. So df.dropNa will drop columns or rows. If you want to drop columns, you'll need to specify axis equals 1. You'll need to pass in that argument. And the thresh argument, which stands for threshold, can be used to specifically drop only columns with less than a certain amount of missing data, hence why it's called threshold. So if you have some columns with only one missing data point and you have some with 10, maybe you'll only want to drop those that have a lot of missing data, so the 10, and that thresh argument is very useful for that. If you want to fill in the data points with some actual data, then you can use df.fillNa, and then whatever you want to fill them in with. You can fill them in with specific numbers, or you can even fill them in with an average of all the numbers in that column. You can do a lot of things with that, but that's essentially how you fill in those missing values with whatever you want. Now, about null values. More about null values, rather. To count the amount of null values in a data frame, you can use df.isNull, which will return a data frame with true and false values based on whether or not each data point is missing. If you want to get the number of missing data points per column, you can use df.isNull.count. That'll give you the exact number. DropNa will drop null values. We covered that. FillNa is will fill a null value. We covered that as well. Awesome. Thanks for listening to the Pandas lecture. I'll see you in the implementation notebook.